So let us try to summarize an entire design flow, right? So first step is to specify our design, right? And we have two types of design entries over here. So it could either be a text based, okay, or it could be a schematic based, right? So these are the two ways by which you could perform the design entry. So in the text base, you could either specify a VHDL source code or Verilog source code, okay, and then we have a system Verilog source code. So these are the three popular language that we frequently utilize. Then in the schematic based design method, here we use a block design, right? So as we progress towards an IPs, we will be understanding more on this, right? So once our source been specified and along with this we completed the behavior that we are intended, okay, the next step is to check whether it is operating functionally correct, right? And how we verify it, we basically apply a stimulus to an input and observe an output, right? And that is done by the step 2, which is a behavioral simulation, right? So behavioral simulation could be divided into 3 categories. So it will be a pre-synthesis behavioral simulation. So let us assume we haven't performed synthesis as well as implementation. So that represents the first simulation where we just apply a stimulus, okay, and then observe the response that we are getting on an HDL core, right? So that is pre-synthesis behavioral simulation. Next one that we have is a post-synthesis behavioral simulation, right? So after we perform a synthesis, we again perform a behavioral simulation because there will be the differences in the. So behavioral simulation could be divided into 3 categories, right? So first is when we haven't performed a synthesis, okay, that is where we perform a functional verification. So just we have performed an implementation of our system, okay, with a source code. So behavioral simulation could be divided into 3 categories, right? So we haven't performed a synthesis yet, and then we are just checking whether our HDL is behaving correctly, right? So that is the first behavioral simulation. The next one is after we perform a synthesis, we again perform a verification of our system functionality. That is the second behavioral simulation. Now there we could also verify whether timings are also correct or not, right? And the third is when we perform an implementation, right? So these are the 3 different kind of behavioral simulation that we'll be performing, right? Synthesis transform our HDL code to something that our FPGA understand, right? So it consists of nets and cells. So cell represent the primitives which are available for a specific device family, right? Something which we could do to optimize the primitives that have been invoked by default by Vivado is to utilize the settings, right? And these are the optimization strategies. So common optimization strategy include the number of PUBGs that you could, okay, PUBGs that you could invoke in design. And the second one that we frequently utilize is the encoding style, okay, when we have a complex FSM. The third one could be whether you want to control the dynamic power dissipation, okay, so adding a clock gating. So these are the 3 popular techniques that we frequently utilize in a synthesis. Now you could see that when we specify our HDL, so HDL will be transformed to an FPGA primitives, okay. So it becomes mandatory to verify the functionality, whether our device or whether our system still behaves as expected, because when we perform a behavioral simulation prior to synthesis, so there we consider an HDL code, right? Now HDL code is transformed into a primitives, so it becomes mandatory that you, even though if you do not apply the synthesis strategies, it becomes mandatory that you perform a behavioral simulation, right? So this is the post synthesis behavioral simulation, okay, and this could be referred as pre-synthesis, and pre-synthesis basically mean that it is also pre-implementation, okay. And the third category is post-implementation, okay. Then once we have our design, now here we need to specify, before proceeding for an implementation, we need to specify a constraints, right? That is mandatory. So we'll be choosing, depending on the port that we have in our source code, we'll be connecting it to the specific peripheral where we want to connect them, okay. And that is mandatory because utilizing them are Vivado will decide where the logic should be placed in an FPGA die, right? So here constraint should be added mandatorily. Once that is done, we will proceed to an implementation, right? This will automatically do the placement. Now, as soon as we specify a constraint, the Vivado will automatically choose the most suitable site depending on the pins that we specify, right? Here we could also adopt some of the strategies if your designing required certain specific constraint. Okay, so this include the area constraint or timing constraint or power constraint. Okay, so we could adopt the optimization techniques, okay, by adopting the implementation strategies while we are performing an implementation. So this could be done by going into a setting of an implementation and choosing the specific optimization strategy, right? So once your design is implemented, again you need to perform a behavioral simulation, right? So this basically represent our third behavioral simulation, which is post implementation behavioral simulation. So once implementation is done, the next step is to generate the programming file, okay, and then you basically open a hardware manager to program an FPGA with the generated bit file. So after this 5 steps are completed, in a case if you require to debug a design, then we basically add the debugging technique. So this includes ILA and VIO, right? So this is an entire flow that we follow for developing an application on an FPGA, right? So we'll just be summarizing here one by one. So the first step is the design entry. Now design entry could be text based or it could also be the schematic based, right? So once you specify a design with an HDL code, we will be performing the behavioral simulation, right? So this represents our step 2, okay, and this is basically pre-synthesis behavioral simulation. Then the third step is to perform synthesis, right? So this will basically transform your HDL to the primitives, okay, FPGA primitives that is available for the specific device family which you have chosen while creating a project, right? Here also you could adopt certain optimization if you require to, if you have a specific constraints, okay, so you could adopt an optimization technique. So these are usually the resource optimization, right? Then as you complete your synthesis, here after this we need to perform post synthesis behavioral simulation, right? So this completes our step 4. So once it matches to the expected result, okay, once it gives us an expected result, the next step is to perform an implementation. Now we could adopt here also an optimization strategies, okay, if you want, or you could just stick to the default optimization strategies which are available, right? So once you perform an implementation, you basically need to perform post implementation behavioral, okay, simulation. So once you complete this, you go and generate the bit stream, okay, so this should be followed by the generation of a bit stream, right? And then we could just program our FPGA, right? And if you are not getting an expected result, we proceed with an debugging, right? So we check for an error and again we go ahead and modify our code, right? So basically we will again be jumping from a debugging step to an HDL code, right? So here we'll again be performing a modification, again we'll be following an entire step, right? So this is how we will be developing an application on an FPGA, right?